So I will be giving a preview of something we are working on, which is autoscaling. And I'm sure a lot of you are excited about autoscaling. So my name is Eric Veld, and I'm a developer advocate at HashiCorp. I know everybody just wants to get to the demo and see how everything works. But to start off, I just want to quickly look at autoscaling and why do we want to autoscale workloads and what are some of the use cases. So some common use cases for autoscaling is when suddenly load in our environments change, and instead of having to adjust our jobs, change the count of a task group, resubmit the job, or worst case, having to commit it into Git, wait for the build pipeline to finish, and then it getting deployed. We would like our applications to scale dynamically, right? So if we get an unforeseen increase of traffic, say for instance, we launch a new product and it's super popular, and suddenly we get 10x traffic, we want our application to be able to automatically adjust to that workload. Other types of loads could be events such as Black Friday, where we know when we can expect these peak and idle times in load, right? Because we know for each of the regions, when people will wake up, when they'll try to buy everything available in any store. And we know that we want to scale up at those time points. And then once that region goes back to bed, we might want to scale down our workloads in that region and then scale up for the next time zone, for instance. Another reason could be where we're running different types of workloads in the same environment. Say, for instance, you're running some background batch jobs, some machine learning jobs, some big data jobs, and then our core applications. Well, during peak hours when users are visiting our websites, we might want to focus all those resources on the core applications. And then say, for instance, we might still want to run some of the big data workloads, only we want to reserve just a fragment of our resources for those jobs. And then in the evening, when the load starts to go down, we might want to allocate more resources for these big data jobs or these batch jobs that we want to run at those times. And normally it's an issue with noisy neighbors, where if suddenly these big data jobs take all our resources, our core applications are then not running appropriately anymore. And then finally, we might want to scale based on useful metrics, because in the end, what matters is the user experience that we deliver to our customers. And if we have a website and trying to buy an item is very, very slow and the website is not responsive, we might want to address that by scaling up, right? So this might not be just the load of an application, but the important metric that we want to scale on is actually latency, because that is the end result that the user actually notices. Now, there's a few types of autoscaling, and I'm going to mention 3 of them, and we're going to focus mainly on the first one today, right? So the first type of autoscaling is horizontal application autoscaling, where we actually horizontally increase the number of instances of our applications to handle the additional load, right? So if we translate that to Nomad, this would be the number of instances of a task group inside a job, right? Then another way to scale is actually vertically, where say for instance, we're running a database or another application that is quite resource hungry, and we actually want to scale it up vertically, so give it more resources, both in requests and in limits. And then if it doesn't need those resources anymore, we might want to scale those down again. And then finally, there's also cluster autoscaling, where we actually scale up the number of nodes that our applications are running on, which we can then use to either scale up vertically or horizontally. right? So the focus of my talk today will be the horizontal scaling of applications. And this is actually a problem that many have already tried to solve. And I'd like to give a shout out to some of the community projects that exist that try to solve these problems. One of them is Scalat from Trivago. And then James Rosell was involved in quite a few of them. You might call him Mr. Autoscaler. So we have Replicator from Elsevier, and then Chemtrail for actually scaling up the clusters, and then Sherpa for scaling up the workloads. And then we have Under Armour Libra. So everything I will be showing from here on is work in progress. So there'll be dragons and things might change. So if you see syntax, it might be that over time these will change. First, I want to take a look at how does an autoscaler work. And it's basically a closed loop control system where we have our desired state and we have our current state. And then every time we measure if we are now in our desired state, and otherwise we have to adjust the inputs and then measure again. And if we translate that to Nomad, then it would look something like this, where we have the policy that goes in as the set point, and then we match that with the strategy, and then we try to adjust the number of nodes and then check again the inputs to see if the adjustments we made actually change the metrics. And then if it does, then we don't need to scale anymore. If it doesn't, we need to actually adjust the values again. You can actually provide metrics from Nomad itself by exposing the allocation metrics or the node metrics, and by exposing those as Prometheus metrics, for instance. But to get much more meaningful metrics, we recommend using external APM tools such as Prometheus, or maybe services such as Datadog to get those metrics. And the way the autoscaler is actually built is very pluggable. So it relies on a number of plugins. And this is actually very useful because every user has a slightly different use case in which cases they would like to scale, or the inputs that they have on which they want to act when scaling. And the way it actually works is these plugins, they have well-defined interfaces, and then the autoscaler agent actually calls those interfaces on those plugins to evaluate if any actions need to be taken. So if we take a look at the different types of plugins that are in the autoscaler, we have the strategy plugin, which basically compares the current state of the system with the desired state of the system, and then produces a set of actions that need to be taken in order to reach the desired state. Then we have the target plugins, which actually function as two parts of the control loop. So they function as actuators when they receive an action request from the autoscaler. And they also serve as sensors when the autoscaler wants to get information about the current state of the system. And then in order for us to make decisions on scaling, we have the APM plugins, which will grab or query information from an external system or from Nomad, and then provide that to the autoscaler. So how does this work? How do we actually configure Nomad to start using Autoscaling? Excuse me. So the changes that we have to make to Nomad itself are actually very minimal, and you might actually already have these enabled. So we want to be sure that we are publishing allocation metrics, right? So we want to set that to true. We want to set node metrics to true. And then we want to have the format of our metrics to be Prometheus metrics. right? So we can actually create advanced queries to query these metrics. And then if we have that, we need to start the autoscaler. So the autoscaler has been implemented as a separate process. And in my demo in a minute, I will actually be running the autoscaler on top of Nomad. And later on, we will actually allow the autoscaler to also scale horizontally itself. And all that the autoscaler needs is it needs to know how to reach Nomad in order to call the scale endpoints. We need to specify where we can find these plugins. And right now, there's actually a few plugins that get bundled in here, which I'll show you in a second. And then we can define a strategy plugin and APM plugins. In this case, it's the most basic where I'm trying to grab the information from Nomad itself. So I define the Nomad APM plugin, which uses the Nomad APM driver, and I point it to Nomad so we can actually get information from the system. And I'm defining the target value strategy where we can compare the current state of a query with the value that we want it to be. So say, for instance, I have average CPU load, and I want that value to be average of 1 over my instances. Then the target value will actually compare the current value with my desired state, and then give us a factor of how to scale according to that. And adding different APM plugins is as simple as adding that to the Autoscaler configuration. So if we would like to grab information from Prometheus, all we have to do is define another APM, and we can have multiple of these defined in one configuration file with the driver of Prometheus, and then point it at a Prometheus server that we can then query. So as I said before, there are right now a few plugins that are bundled together. We have the Prometheus APM plugin, and then the Nomad APM plugin, and the target value. But we will be adding on to these later ourselves, and we hope that the community will also start to contribute these values or these plugins as well. And then all we have to do is start the autoscaler with the run command and pass it that configuration that I showed before. And it will then pick up all the plugins that I have defined in there and start listening. Now that we are running the autoscaler, how do we then actually get our jobs to autoscale? So there is a new stanza block, which is the scaling stanza block, which allows us to specify scaling for our task groups. So per task group, you can actually specify if you want scaling enabled, and then define policies as which the autoscaler should react to. In this case, for instance, I wanted to react to the average CPU, and I want the average CPU to be 1 for my instances. And then what we can define is we can actually define a minimum and a maximum number of instances so that we can actually limit it and not go crazy in case we get some metrics and end up with 9999999 instances of our services. And another example of a policy might be where we query Prometheus and we get the number of sessions per instance that is up. And then we have the average of that. And we can, for instance, say that we want the average number of sessions per instance to be 20 or lower. So that's what this defines. I have my normal Prometheus query there, and then the target value. So now let's actually get to the good part and try and show this in action. So I already have Nomad running here and console running here. I'm assuming I will need to zoom in slightly for this to all be visible. So let me first go to the browser and show that I'm actually running Nomad right now, I have a web app running, and all the web app does is report its IP and port. And this web app, currently one instance, is being fronted by an HA proxy. So when we start scaling it up, we will actually load balance between these instances. And then besides HA proxy and my web application, I'm also running Prometheus and Grafana on Nomad right now. And that is so we can actually query Prometheus and then start scaling on that later. So if we take a look here, we can see that my application is actually running. So this is the response from the web app. And we can see the IP and the port that it's running on. And that should actually correspond with the address we have here. Then if we take a look at our metrics, we can actually see that right now there's no load going to our application because I'm not running any load test on it. And we just have one instance of the application, and it's all going to one instance of that application. So let's start throwing some actual requests at this, right? So let's do make load. And for a duration of 5 minutes, I'm actually sending 30 connections to the application, right? So we can see that we're starting to get some load on the web app, and all the requests are now pounding my one instance of web. Well, as long as web can handle that and performance is fine, we don't have any issues, but ideally we'd want to scale up in order to react to this. So let me stop this, all right? And let me actually show you how we're going to change our jobs to actually react to this. Waiting for WSL, always a joy. Okay, so let's grab that first example that I had in my slides and start scaling on the average CPU load. So we're going to grab the average CPU load from our Nomad metrics, and we want the load to be a maximum of 1 per instance, right? And if we take a look back at here, we can actually see that we're generating way more load than 1. So let's submit this new job. Right, so we're sending that job in, and let me, at the same time, start opening the logs for the Autoscaler, which I'm not running yet, so let's actually start running that. So I'm actually running the Autoscaler on top of Nomad. And as you can see here, we're now deploying that. And it's now running. So let's grab the logs of the Autoscaler so we can actually see it react to the information. So here we can actually see that it's creating a PM. It's not doing anything. It's not telling us about any scaling actions, right? So we're actually running our new version of the application. In the load, we don't have any load and we have one instance. But if we now actually start generating the 30 connections again, we now see the connections ramp up, and we should actually start seeing the Autoscaler start making decisions. So what we can actually see here is that the Autoscaler actually wants to scale from 1 to 2 because the factor is 3.0, right? And it actually noticed that it was not high enough, so it actually wants to scale from 1 to 4, now actually 1 to 3, because that load's actually bouncing a little bit. we should now start seeing that different instances of the application are going to show up here. Waiting for the delay in Prometheus. Here we see 3 instances of our application, and we can see that we have an average of 10 connections per instance. And if we take a look at the web app, we actually see that it is scaling because load of each of these instances is actually above 100%. And then if we actually kill the load, we will actually see the autoscaler react to that. There we go. And we can now see that it's trying to scale from 8 to 1 because there's no load anymore. So this is a pretty abrupt stoppage of the application right now. So the autoscaler actually sends a stop signal to the applications. So applications can actually gracefully handle the shutdown of the sessions and stop handling traffic. But later on, you'll be able to tune the actual grace periods and how fast it should scale up and scale down and how long it should wait for each of these. So that's a very basic way of scaling up. But if we want to do something more fancy, like the Prometheus query that we had before, where we're actually taking a look at the number of sessions and then spreading those out over our instances, all we have to do is define Prometheus as a source and then create a new query. And then in this case, we want the number of connections to be 20. So if we make Web Prometheus, we've now submitted our new job, right? And we can see that there is now a source Prometheus policy registered. And then if we actually start generating load again, we will actually see that it's slowly starting to scale up. And this time it'll scale up way less dramatically than it did before. So right now it's actually trying to scale up to 2. Because the metrics we're trying to scale on is way less fragile than CPU load. So right now, the average number of connections is 30, and we should see that even out to about 20 as soon as all the new instances start coming up. So we can see here now that we're starting to spread the number of connections between our applications. And as soon as the load goes away, it'll then scale down again. All right, so if I take this away, we will actually see that Nomad has already scaled it down immediately. And this also works for extreme workloads. So if I do make extreme load and I'm trying to send 100 connections to it, it will scale up way faster because it actually determines the factor that it needs to scale up with. So as we can see, we've now scaled to 5. And if I move zoom out of the way, we can actually see that we are being load balanced over our different instances of our application to handle that load. Okay. Back to this. So with that, thank you. That was my presentation.